Hey guys, Dr. Martin here. I have been receiving a lot of emails from all of you regarding the Stellarium 2 lab looking at a solar eclipse. And specifically, I got a lot of questions about the table and also the angle of elevation, or the elevation, angle, altitude, etc. So it kind of looks like this if you've downloaded it in Microsoft Word or any other word processor. So I'm going to look at specifically the angle of elevation, and I'm also going to go through the location A for how to get these values. So first and foremost, make sure you have Stellarium up and running. Make sure you're on whatever location you need it to be on. I'm actually going to zoom that back down, maybe. There we go. And we're going to make sure we can see our event. So I'm currently at the event, and you can see that right there, beautiful. Of course you can zoom closer. Now specifically I'm wanting the moon, so this is actually the sun, but the sun and the moon are in the same position at this point. If I'm looking for the angle of elevation, I'm actually looking at this value right here, this altitude. So it's azimuth altitude in the data display. And I'm looking at specifically the altitude. In this case, it's showing me 62 degrees, 45 arc minutes, 56.2 arc seconds. So that would be my angle of elevation for this particular location, looking at this particular object. Now, the next thing here is if you look at the RADEC, the right ascension declination coordinates, for Julian 2000, that's the J2000 in parentheses here. Notice it gives you another set of coordinates. The first one is going to be the right ascension, which is looking at hours, minutes, and seconds. Sorry about that. The next one is looking at your declination, which is actually the most important part that you're going to use for this assignment. And notice it says it's 11 degrees, 56 arc minutes. 35.1 arc seconds. So that's the information that I need over here. So I'm just going to simply go back, type that in. So remember, this one's altitude, looking at the angle of elevation. So that's 62 degrees. I'll go back and make that a little degree symbol in just a second. 45 arc minutes, 56.2 arc seconds. You can make this a degree symbol pretty easily in Microsoft Word. Okay, and then down here for location A, I'm looking at right ascension declination. Whenever it's giving me that data feed, it is for the center of the object. Now, for most objects, that's the same as anywhere on the object because it's really, really small and really far away. However, if I'm looking at something like the moon, which is relatively close, now we can get the center and we can get the edge. The center value is given to us, again, in that data display. The edge we have to estimate. So we'll come back to that in just a moment. So let's go ahead and get this first right ascension declination. So that's 10 hours, 3 minutes, 10.34 seconds. For the right ascension, and then it's 11 degrees, 56 arc minutes, 35.1 arc seconds for the declination. Alright, now let's talk about this edge real quick. So in Stellarium, going back for just a second, you have two grid systems down here. You have the azimuth grid, and then you also have the equatorial grid. You need to turn on the equatorial grid. The hotkey is E. So I'm going to go ahead and turn that on. And this is far too far away, so I need to zoom in like crazy. So I'm going to get real close to the moon here and estimate my values. Now, I'm specifically looking at where I have, it's a little hard to see, but where I have my leading edge, which is going to have that positive arc second value here. It's not going to have an S after it, it's going to have the arc seconds in tick marks. So So we're going to keep getting nice and close until we're satisfied. Everybody's going to approach a little bit differently to this assignment. But the closer you get, the much more accurate your data can be. So I'm going to use this line right here. So I zoomed in. I'm at a field of view of 0.0395 degrees. Some of you might do this a little bit further. Some of you might get a little bit closer. It just depends. But I'm going to use this line right here of positive 12, 8 arc minutes, and 10 arc seconds. And that's going to be the estimation for the declination of the moon's edge. So 12 degrees, 8 arc minutes, and 10 arc seconds. Oh, 10 arc seconds. There we go. And that's it. So now you're looking at these other two columns here. These other two columns are actually obtained by using this formula right here. And so when you put this into a calculator, for example, looking at this first declination for location A, the degrees, obviously, it's 11 degrees. The minutes that you obtained was 56 arc minutes, and your seconds are 35.1. Now, if you're popping this into a calculator, make sure you're following order of operations. It might help to put some parentheses around, especially if you're using an iPhone calculator, as I know I do in some cases. And so this will give you some degree value that is now converted into decimal. That response will go here. And then do the same thing on this one. All right, good luck, guys.